The scientific enterprise is a vast, interconnected web of data, research, and discovery. At the heart of this web is the principle of data sharing. Data sharing not only advances the scientific output of the nation, but it also promotes equity, giving all scientists, especially those with fewer resources, the opportunity to participate in advancing science and technology. This is the essence of the democratization of science. This training video will follow several characters whose success is achieved through the intertwining of findable, accessible, interoperable, and reusable data which has been shared. First, we will watch Joanne Sun, an early researcher who creates a more accurate base calling algorithm for sequencing, interact with Dr. Jean, a senior researcher who directly benefits from her algorithm.
Hi, Miss Sun. I am looking to have some nanopore sequencing performed on my DNA samples.
Absolutely. I actually just published a new base calling algorithm using nanopore technology. Perhaps you should try using this for sequencing as well. I think it would enhance the accuracy of your sequence runs.
Oh, I think I've heard of this. I saw a recent publication from Dr. Green where he acknowledges your algorithm and how it enhanced his focused study on mouse genomics. How did you come up with it?
Well, I was performing literature research and stumbled across a recent paper comparing algorithms for base calling using nanopore technology. I had some ideas for an improved algorithm, so I turned to Zenodo and found test data from Dr. Green's work on sequencing using nanopores. This shared data permitted me to create, test, and refine the improved algorithm, which I then published for the benefit of the scientific community.
I would love to give it a try. If it's successful on my samples, do you think we could apply it retrospectively on my previous sequencing runs? That way, all of my experimental data would use the same enhanced base calling algorithm.
Great idea!
As you can see in this example, Joanne's reuse of Dr. Green's FAIR data benefited not only her personal research career, but also the technology of the University Genome Center and the research community. Next, we will follow the journey of Max Barton. Max is an undergraduate computer science major at a small school with limited research resources and a very diverse student body. He has an interest in applying artificial intelligence to problems of classification using supervised and unsupervised learning. Let's watch how Max learns from his professor, Dr. Code, and uses FAIR shared data to his benefit.
Hi, Dr. Code. I really enjoyed your lecture on AI yesterday. I'm thinking about participating in undergraduate research, but I'm struggling to find a research topic. Do you have any ideas?
Well, if you're interested in clinical pathology, I may have an idea for a research topic for you. Currently, manual review of biopsy specimens for cancer diagnosis is a labor-intensive process. Pathologists must first scan specimen slides for likely regions of interest indicative of abnormal cells. Finding all these regions is not easy, as the process of manually scanning an entire slide is time-consuming and often involves peers to provide a second opinion. An effective AI-based algorithm could bypass this manual process by automatically identifying potential regions of interest over an entire slide. That way, pathologists could focus on discovering abnormalities within the likely regions of interest, cutting down the overall time and effort expended in the specimen analysis and lowering the probability of misdiagnosis.
Wow, that's so interesting. This seems like an impactful challenge because undetected abnormalities could lead to a cancer misdiagnosis. I have an algorithm in mind that could work well, but I'll need to do some testing and validation. Do you know where I can find cancer pathology images?
There are open repositories that exist where researchers deposit images from their studies. Perhaps digging around on the web will yield the type of data you need. I'm happy to review what you find.
Great, thanks. I'll do that.
Max scours the internet for repositories with cancer imaging data. He finds the Cancer Imaging Archive, which hosts microscopy images of cancer pathology. He is able to access and use images from TCIA to validate his algorithms.
Hi, Max. How's your research project going?
Great. I'm actually close to finishing up. The algorithm definitely shows promise. It turns out that TCIA has a large collection of searchable, well-curated, de-identified human histopathology cancer images, which I could use for development and testing. The standard format made it really easy for me to search for and utilize what I need. The quality intake process of TCIA ensured there were no low-quality slides, while the de-identification addressed any privacy complications involving human subjects. In addition, the API also made it straightforward to access the images programmatically using Python.
That's fantastic. I'm so glad to hear there was so much high quality, publicly shared data from NIH funded research for you to use. Do you plan to publish your algorithm?
Yes, I'm working on a submission to the Journal of Artificial Intelligence. I still can't believe that I was able to accomplish all this research at such low cost by reusing shared data and using a small amount of cloud computing time.
It is incredible to see how the democratization of science can impact research. You should plan to attend a suitable research conference this year to share your work.
Following the publication of his work, Max attends the AI in Life Sciences conference.
Hello, are you Max Barton?
Yes, I am.
Great to meet you. My name is Dr. Tact. I do research in oncology. Thank you for developing an automated image analysis tool. It's been incredibly useful for my research team, and I plan to reference it in my future publications.
Wow, I'm so glad this tool is of interest to scientists. I recognize your name from my research. I used the images you shared in TCIA for developing and validating the tool. I guess you could say we both worked together to develop the algorithm.
Let's exchange contact information. I would love to collaborate with you on developing additional tools for use in histopathology.
Absolutely. I would be honored to work with you. I will set up a GitHub module for our joint development of additional tools.
In both examples, shared data conforming to FAIR principles becomes an enabler for all members of the scientific community. We see democratization of science in action, leading to more advances, more cures, and better health for the nation.